Okay, so today we're doing 11.4, which is about inscribed angles. And the first thing we're going to talk about is the inscribed angle theorem, which has a few different cases here. So the measure of an inscribed angle is half of the measure of its intercepted arc. Okay, so the angle is going to be half of the arc, or you can also look at it as the arc is going to be twice the measure that the angle is. So for all of these, you're looking at angle ABC. So this angle ABC would be half of AC, okay, the measure of that arc. Here's another one, angle ABC would be half of AC, and angle ABC is half of AC. Right, so when we look at example 1, we have to find the measure of PRU. Okay, so we're finding the measure of PRU, which is this angle right here. So what we want to do is we want to see if we have the intercepted arc. So the intercepted arc is just PU. What smells in here? Get it? Right, so that angle is going to be half of the arc. We know that that arc is given to us is 118 degrees. Okay, and then so when we're doing half, okay, think of half of 100 and then half of 18. Okay, so yep, 59. Half of 18 is going to be 9. Half of 100 is 50. Okay, so that's going to be the measure of PRU. All right, now the next thing we're going to find is the arc of SP. Right, so the arc SP is what we're trying to find. This is the arc here, and then we are given the inscribed angle, which is 27. Right, so remember I told you you could think of the arc as double this angle. So if we think of this in terms of our equation, the angle is half of the arc. Okay, or you can just take that angle, and when you're solving, you're going to be doing what to both sides? Multiply by 2. Okay, so hopefully when you start to recognize this, you'll just be multiplying by 2. That will be the measure of your arc. Okay, so the angle is half of the arc, and the arc is double the angle. Ready for the next page? All right, so then we have another theorem here, and this theorem tells us that an inscribed angle subtends a semicircle if and only if the angle is a right angle. So what it's saying is that if you have a right angle, then the arc is going to be a semicircle, which means it's going to be equal to what? Has to be double, right? So if this is 90, think of half of your circle. A full circle is how many degrees? No? 360, right? So then half of that would be your 180. Okay? And so, yeah, when it says subtends, it's the same thing as it's intercepting that arc. Okay? But that is a new word for us. All right, so for example 3, we're going to find each value. The first value we want to find is A. And they give us that angle Z is going to be 5A plus 20. So let's talk about what's in our circle. So first we have this segment WY, which is the what of the circle? Diameter, right? So this is the diameter, which means that you do have a semicircle. So your angle, WZY, is a right angle because it's inscribed in a semicircle. Okay, so I'm just going to show you that semicircle that it's inscribed in, which is right here. Okay, so this angle here intercepts this arc, which means this is going to be a right angle. Okay, so because it's a right angle, we know that 5A plus 20 is going to equal 90 degrees, and then we can just go ahead and solve that for A. So we'll subtract 20 from both sides, which is going to give us what value? 70, and then we're going to divide it by 5. Do you guys know what 5 times 12 is? 60, which means that 5 times 13 is 65, and then 5 times 14 would be 70. All right, and then for part B, we're trying to find the angle LJM. So LJM, which is this little angle right here. Okay, so if we're trying to find that angle, what we're trying to find is this arc. Okay, so we're trying to find the arc LM. Now, do you notice anything else about this arc here? Yes, so it also intercepts this, well, this angle is going to intercept this same arc. Okay, so if this is 3B, this is going to be double that. Okay, and that means that both of these together are going to be equal. So if they intercept the same arc, okay, then these two have to be equal. So the measure of LJM is equal to the measure of LKM because they intercept the same arc LM. So that's the reason why we're able to set 5B minus 7 equal to 3B. So I'm going to get all my B's on one side. Divide by -2. When I have a negative over a negative, that becomes a positive. And you could also write it as 3.5. That's your B value. What we're trying to find is LJM. So we know that the measure of LJM is equal to 5B minus 7. So it's going to be 5 times 3.5 minus 7. So if we want to do this without a calculator, we could do 5 times 3, which is what? 15, and then 5 times a half. What's 5 times a half? 2.5. So if we do 15 plus 2.5, we get 17.5, and then we're going to subtract 7, which is 10.5. Okay, so that's going to be your measure of LJM. All right, so ready for the next page? Okay, so our next theorem, 11-4-4, tells us if a quadrilateral is inscribed in a circle, so you have to have a quadrilateral inscribed in the circle, then opposite angles are supplementary. Right? So what you'd have to be given is that this is inscribed. So remember, if it's inscribed, that means it's inside the circle. Do you guys remember what the other one was called? No. It was circumscribed. That's when you have the circle inside of it. So the shape is going to be inside the circle here. Uh-oh. And really this should be A, not X, because they call it ABCD. So angle A and angle C are supplementary. So that's what they mean by opposite angles. Okay, so that means that the measure of angle A plus the measure of angle C would have to equal what? 180. And then the same thing's going to be true for B and D. So the measure of angle B plus the measure of angle D is also going to be 180 degrees. Okay, because remember, when they're supplementary, that means together they're going to equal 180. Okay, so we're going to use this information to help us with example 4, and we're going to try to find the angle measures of GHJK. So that means we're going to find angle G, angle H, angle J, and angle K. Okay, so when it says to find those, this means that we're going to find the 4 angle measures in quadrilateral GHJK. Okay, so remember that we know if the quadrilateral is inscribed in the circle, then opposite angles are supplementary. Is this inscribed in the circle? Yeah, how can we tell that it is? Yes, okay, the points are on the circle. So not only does it have to be inside it, but all of your points are going to be on the circle itself. Okay, so it's not just floating around inside there. The vertices are going to touch the circle. Okay, so then that means that the measure of angle G plus the measure of angle J is going to equal 180 degrees. So we're not setting them equal to each other. We don't know if they're equal. We know that they're supplementary. Why am I not setting these two together? I don't have what H is, right? So we're going to have to do some investigating. So for G, we have 3B plus 25. For angle J, we have 6B plus 20. So then I'm going to combine my like terms. So 3B and 6B are going to give me 9B's, good. And then 25 and 20, 45. So then what am I going to do with my numbers? I'm going to subtract 45 from both sides. And what will that give me on the right? Okay, so now I'm going to divide by 9. Okay, and 9 goes into 13 how many times? 1 time. And then when I subtract them, I get 4. So how many times does 9 go into 45? 5 times. So your B value is 15. Okay, so now that I know that B is 15, I can find all of these. So I can find the measure of angle G, which is 3B, so 3 times 15 plus 25. What's 3 times 15? 45. 45 plus 25 is 70. Okay, and that is the measure of angle G. I can also find the measure of J, which is 6B plus 20. You guys know what 6 times 15 is? 90. Because if you multiply 15 by 3, you get 45. 45 and 45 is 90. 90 plus 20 is 110, and that's angle J. And then what's the last one I can find? K. So then I have 10 times 15 minus 69. What's 10 times 15? 150. Okay, now when you're doing mental math with this, what I would do is I'd subtract 70. So 150 minus 70 would be what? 80, and then you can just add 1, because that's what you did here, is you went up 1, so it'd be 81. And this is the measure of angle K. So now we can find the measure of angle H. How can we do that? Okay, good. Yeah, there's actually a couple different ways. So one way is that you know that the measure of angle H plus the measure of angle K is equal to 180. So that means the measure of angle H is going to be equal to 180 minus 81, which is going to be what? 99. What's another way you could do it? Okay, good. So how the quadrilateral has how many triangles in it? 2, right? Because you would draw one diagonal here, which means the degree of a quadrilateral is 360. And then you could just do 360 minus 70 minus 110 minus 81, you get 99. Alright, so after your quiz, I'm going to have you work on your homework, which is on page 776. We are in section 11.4. And we're doing numbers 2 through 5, 7 and 8, 10 through 13. Okay, and I know that most of your desks are already in quiz position, but if they are not already, will you